Hi kids, this is Mrs. Mooney, and this video is about algebraic expressions and equations. So the first thing we're going to do is really boring. We're going to copy down some definitions. So when I put those up, I want you guys to press pause, copy them all down, and then we will discuss them. Alright, here they are. The first one is variable, and that's the letter that you use to stand for an unspecified real number, like usually x. The next one is expression. That's a collection of variables and constants connected by operation signs, like 2x plus 7, something like that. It's an expression. An equation then is different from an expression, and the key difference is an equation has an equal sign, and that's a statement saying that two expressions are equal to each other. So please watch out for that, expression versus equation. The terms are the part of the expression that are added together. And then the coefficient is the letter, or the number that goes with the letter. So if I had 2x, then the coefficient would be 2. To evaluate means to substitute a given number for the variable. So if I said evaluate 2x when x is 5, you would plug a 5 in for x. And then simplify just means to take an expression. We're not solving, there's no equals, but we're taking an expression and making it a simpler but still equivalent expression. Okay, some more things you need to know. The order of operations. Hopefully you already know this, but the order of operations, PEMDAS, parentheses, exponents, multiplication and division, which are interchangeable, and then addition and subtraction, which are also interchangeable. And then we have solving equations, which just means we're going to work the order of operations backwards to isolate the variable. So now if you're ready, we will do some real math. Alright, here are 3 examples that I want you to try and work out. And maybe you try and work these out, just push pause and try to do it yourself before I explain. Alright, so we've got 2 plus 3 times 2. Our order of operations says that multiplication comes before addition. So we're going to multiply that part first. 2 plus 6. Then we add, so 2 plus 6 is 8. Alright, we have 6 times 2 plus 1. PEMDAS says that multiplication has to go first, so 6 times 2 is 12 plus 1. 12 plus 1 is 13. You have to go in that order, because see, look over here. If you went 2 plus 3 is 5, and then 5 times 2 is 10, you would not get 8. But that's wrong. If you, in this case, left to right works, but that's just because of the way it's written. In this case, okay, PEMDAS says multiplication and division, but we're going to start with the division and go left to right. So we're going to say 5 minus, and then 8 divided by 2 is 4 times 3. Now we're going to do this multiplication, because you do it left to right. So now we have 5 minus 12, and 5 minus 12 then is negative 7. So who's seen this one on Facebook? There's an interesting article about it here, and if you want to go to it, you're welcome to go read it, debating how to solve this. But we're going to do this the textbook SAT, ACT way. So when you see a problem like this, here's how you're going to do it. The P in PEMDAS stands for parentheses. So we're going to do that first. 1 plus 2 we all know is 3. So now we have 6 divided by 2, and then when you have 2 in front of parentheses, that's a times, and then we know our parentheses is 3. And then PEMDAS says multiplication and division, but they say go in order from left to right. So then we're going to go 6 divided by 2 is 3, and then times 3. And the correct answer, if this was on the SAT test, would be 9. I know a lot of you will be tempted to do this first, right? 2 times 3 is 6, and then 6 divided by 6 is 1. And that's that huge debate on the internet about it. But this is the proper way to do it, at least as far as our class is concerned. Alright, here are some problems where I'll ask you to evaluate. For x equals negative 1. Evaluate means substitute. So we're going to take the negative 1 and plug it in. We've got 2 times negative 1 plus 3. And we take our order of operations as we need to do the multiplication first. So negative 2 plus 3. And that is going to give us 1. I always box or circle my answers, and I want you to do that as well, so that whoever's grading it or looking at it can find the answer. Alright, the next one we have is 2x squared plus 3. So we've got 2, and then in place of x I want negative 1 squared plus 3. Alright, PEMDAS says we do parentheses first, so I have negative 1. Then the e says the exponent. So negative 1 to the second power is the part that I'm going to do first. So 2 times, and if I square negative 1, if I say negative 1 times negative 1, I'm going to get positive 1. So 2 times 1 plus 3, and then we're going to multiply first. 2 times 1 is 2, 2 plus 3 equals 5. Alright, the next one, the absolute value of 2x plus 3. So the absolute value of 2 times negative 1 plus 3. Alright, we treat absolute value bars the same way as we do parentheses. So we're going to do what's inside of there first. And 2 times negative 1 is negative 2, so I still have my bars and then negative 2. Absolute value of negative 2 plus 3. The absolute value of negative 2 is positive 2, so I have 2 plus 3, and that equals 5. And then this last one, I have 3 minus 2 times x. So we're going to plug in the negative 1. 3 minus 2 times negative 1. PEMDAS says we need to do the multiplication first. So 3 minus 2 times negative 1 is negative 2. Then we're going to multiply this negative out here times this negative in here, and a negative times a negative becomes a positive, 3 plus 2, which is also 5. So this and this and this are all equivalent expressions when x equals negative 1. Alright, here's a couple of fun ones. We're going to simplify now. So that means that we're going to just take our order of operations and make what we have still the same. It's still going to be equal, it's just going to be more simple. I split these up into 2 different colors because it's going to get messy. Alright, so we have 5 minus, and then a bracket, and then 4 minus, and then a parenthesis, and then 2 minus x. So PEMDAS, we do parentheses first, and you always want to do your innermost parentheses first. So we're going to do 2 minus x first. Alright, there's nothing we can simplify within that parenthesis. So now we're going to multiply everything that's in that parenthesis by that negative sign. So now I'm going to have 5 minus bracket, 4, and then I have minus 2, and then I have minus x. That becomes plus x. Be very careful. You're going to see this a lot in Algebra 2. You're going to see a minus in front of a group. Make sure that you always distribute it to both terms. Alright, so now we have 5 minus, and then bracket, 4 minus 2 plus x. So now we can simplify by putting this 4 minus 2 together. We have 5 minus bracket. 4 minus 2 is 2 plus x. So I've got another minus sign here that I need to distribute to both of these. So I'm going to have 5 minus 2 minus x, and 5 minus 2 is 3, so 3 minus x. That is simplified, and this is equivalent to this. It's just simpler. Right, let's look at the purple one now. We've got 2x minus 3, and then a brace, and then 4 minus 2, and then a bracket, and then x plus 2, and then a parenthesis, and then x plus 1, and then they're all closed. So we're going to start from the smallest set, the most inside set, and work our way out. We've got x plus 1, can't do anything with it, but we can distribute this 2 to both of these. So I'm going to put x plus, and then I've got 2x plus, and 2 times 1 is 2. That still goes in the bracket. And then we can copy the rest of this, because I haven't got to that part yet. Alright, now let's combine the x plus 2x. Let's make it 2x minus 3 and 4 minus 2, and then x plus 2x becomes 3x plus 2. Now I'm going to need to distribute this 2, and it's a minus 2, so make sure that you pay attention to that. We're taking negative 2, so I've got 2x minus 3, and then 4, and then negative 2 times 3x would be minus 6x, and negative 2 times 2 would be minus 4. So now I have 4 minus 6x minus 4. Well, the 4 and the minus 4 are going to cancel each other out. 4 minus 4 is 0. So I've got 2x minus 3, and then the negative 6x. Now I need to distribute this negative 3. Always distribute it with the sign. So I've got 2x, and then negative 3 times negative 6x is going to be plus 18x. And 2x plus 18x makes 20x, and that is fully simplified. Just always start at the beginning and work your way out. And I know some of you are lazy and don't like to write, but the more steps that you actually write, The easier it is for you if you screw it up, for you to look back and figure out where that happened. Or if it's your test and I'm the one who has to look back, it's easier for me to look back at all your work and see where the mistake happened. Alright, and now we're going to actually solve. So the difference between the ones we were doing before and the ones we're going to do now are this little equal sign right here. There we go, that equal sign right there. See? So we're going to solve them. So we're going to work our order of operations backwards. So PEMDAS, the last thing is subtraction. Do you see this minus 5? We are going to do the opposite and add 5, and you have to do it to both sides. The addition property of equality says that. So now I've got 3x equals 21. So I've taken care of all the addition and subtraction. Let's take care of our multiplication and division. We've got 3 times x, so we need to undo 3 times x by dividing it by 3. Divide both sides by 3. And you get 1x equals 7, and you're done. You have solved for x. Now, I want you to learn how to write a solution set. A solution set, we'll just have to, hang on. Alright, erased it. A solution set, we're going to say S for the solution equals, sorry about the color there, and then you put these braces, and we put a 7. So when you were asked for set notation, you write it like this. Alright, so let's look at the next one. It says x squared equals 4. How are we going to solve for x? To undo, we don't have any multiplication or division to undo. We don't have any addition or subtraction to undo, but we do have an exponent to undo. So to undo x squared, you take the square root of both sides, and we get x equals, and we're going to do plus or minus the square root of 4. Anytime you are solving and you create a radical symbol in the problem, you're going to put a plus or minus in front of the radical symbol. If it's already printed in the problem, then you accept whatever sign the author put in front of it. But if you create the symbol as you are solving, you put a plus or minus in front of it. It's going to be very important in Algebra 2 this year. Alright, so now we know the square root of 4, so we keep our plus or minus, x equals plus or minus 2. So our solution is going to be negative 2 and positive 2. If we're going to write it in set notation. Alright, now the x plus 3 that I had at the bottom, we'll just do on the next page. Okay, we've got x plus 3 equals x. So we need to solve for x. We need to combine like terms. That's another thing that you're going to do a lot in Algebra 2. You're going to combine like terms. So that means I'm going to take the x terms and put them together. So I'm going to take this away from both sides. And I've got 3 equals 0. Uh-oh, that's not possible. If something is not possible, then that means it's never going to be equal. It's never going to be true. You could think about if you were to graph these two lines, they would be parallel to each other and they would never cross. They never equal each other. So if you're doing set notation, you do either what we call an empty set, which is an empty set, or you can do the 0 with the line through it, because that doesn't mean 0, that means nothing. So if you're used to writing your zeros like that, stop. 0, the number 0 is just a 0, an O. The 0 with the line through it means nothing, not even 0. 0 is not, if you plugged in a 0 for x, it wouldn't work either. So like no solution. That's how you would say no solution. Alright, now let's look at this one. I have 3x minus 4 times x plus 5 equals 0. How many of you want to FOIL that? Oh yeah, you want to FOIL it, don't you? I mean, you see these two things together and you think FOIL, but no, 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 no. Don't FOIL. When you're solving, you don't want to FOIL. You want to get x by itself. You want to set each of these two terms equal to 0. Because anything times something else, if it equals 0, then one of those things or both have to be 0. So 3x minus 4 by itself has to equal 0. Or x plus 5 has to equal 0. So we're going to solve each of those independently. Alright, I should have left a space, but if we do 3x minus 4 equals 0, we're going to get 3x equals 4, x equals 4/3. And if we do x plus 5 equals 0, we're going to get x equals negative 5. So you have two answers. There are two different things that you can plug in for x into this and get 0. Think about the graph. That's a parabola, and it's going to cross the x-axis twice. Once at negative 5, write it in our solution set, and once at 4/3. And it's customary to write them from least to greatest in your solution set. Okay, the last thing we're going to talk about is what happens if your domain is restricted. Alright, so this is the answer to the problem we just did, as the solution is negative 5 and 4/3. But what if I had given you that problem and I told you that the domain is restricted to only positive numbers? Sorry, we're out of room here. Positive numbers. Okay. If I restrict the domain, then only one of those two answers falls into that category. And so if the domain was restricted to positive numbers, your solution would just be 4/3. Or if I restricted your domain to only negative numbers, your answer would be only negative 5. If I were to restrict your domain to only integers, here's where that those categories that we learned come in. We're going to start restricting the domain, so if I restrict your domain to integers, you have to know what integers are. And if I restrict the domain to integers, well, negative 5 is an integer, but 4/3 is not. So only negative 5 would be the answer, the solution. So let's just try one more. If I restricted your domain to counting numbers. Counting numbers. You have to think, okay, is negative 5 a counting number? No, our cavemen were not smart enough to count negative 5 rocks. They didn't think that way. So that doesn't count. Is 4/3 a counting number? No, they weren't that smart either. So we don't have a solution. It's an empty set. Because if I restrict the domain to only counting numbers, there are no counting numbers that will work for x in that equation that we solved. And I just want to add, of course, from the beginning, I never said that, but this one, our domain would have been for reals. And that's the most common domain that we're solving in, is the real number domain. So if I said solve this for reals, then we would have, the original solution. And, I found this joke, and it's perfect for this lesson because we just used the phrase for reals. So for reals, we're done with this lesson for reals. Have a good night.